So before I get into the kind of main part of the presentation, first of all, what is ICRAG? ICRAG is a research center, a national research center based in UCD, but it also brings in researchers from University College Cork, Trinity College, and the real focus is geosciences. So how does our built environment interact with the ground? So obviously there's a tie-up between GDG, where that's kind of our core consultancy strength, and ICRAG, and we're doing a lot of collaboration together. So some of the research that I'm going to talk about today is in collaboration with ICRAG, and some of it predates ICRAG. So the structure of the presentation today, I'm going to give a bit of an introduction into GDG, who we are, and then go on to offshore wind and some of the changes in the market that we've seen from a technical perspective over the last number of years. I'm going to look at why we should explore the seabed. Why is that important, and why is it particularly important for offshore wind in comparison to other industries? And finally touch on a decade of research, both the benefits that come from it, the advantages that this research has for offshore wind, and also some of the frustration that we're here in Ireland for a decade, optimizing offshore wind, contributing to reducing the levelized cost of energy, and yet you look across the Irish Sea and you see a stagnant industry that hasn't evolved in that period. So our European colleagues are taking the advantage and getting all the benefit from this research, but while Ireland kind of stands still. So hopefully that's something that's going to change. So GDG, we are a geotechnical engineering consultancy specializing in offshore wind, set up in 2011. Not the ideal time to set up an engineering business in Ireland for obvious reasons, but fortunately that situation has changed. At the time, we chose not to go down the housing route, not to go down the building route. We were very focused. Offshore wind was kind of where we wanted to be, and we saw the European and the international opportunities there. Since then, we've grown. We've got a team of about 45 engineers spread across offices in the UK and Ireland, and the majority of our staff are PhD qualified. I'd just like to briefly mention those 45 guys, because the research that I'm going to talk about later on is brought together and is a contribution from all of those people. It's not necessarily my work, so I'm kind of borrowing on a lot of smart people's expertise. In terms of the services that we offer to the market, basically we get involved from the very outset in terms of site planning, in terms of site selection, feasibility, and then taking it through survey management, survey specifications, developing ground models, and then taking it through detailed design and hopefully completion. I would love to say that's every project that we've been involved with, but if you think of the timescales of an offshore wind farm, and when the initial concept is first kind of comes to light, and then the timelines for the surveys and construction, realistically we would have had to start the company a decade earlier in order to be involved in all stages. So typically what we have is a range of projects where we've been involved in various stages along the way. So what have we seen from the industry over the last 5 years? And what are the big kind of changes? And this is a very dynamic industry. It's not like your traditional civil engineering industries where you can take out a textbook from 1945 and use those design approaches and they're going to work for your project. This is an industry that changes on a weekly, if not daily basis. We're constantly seeing innovation. We're constantly seeing dynamic change to the better and for the betterment of the industry. And all of those technical advances also lead to reduced costs of energy, and as a result, offshore is getting more and more competitive as time goes on. In terms of the big technology advances, we've already heard of the 12 megawatt machine that GE are producing, and obviously turbine size is one of the big drivers for reduced LCOE. Increasing turbine sizes obviously has impacts on everything that goes along with it in terms of foundation design, in terms of your overall project engineering and your array layout. So what we've seen is an industry that's using bigger turbines, is requiring bigger vessels, has a risk profile that's changing, but the supply chain is kind of rising to meet those challenges, and the supply chain is maturing, and that also is reducing the cost of energy. So if we just look at what those cost reductions look like, because it's all quite recent. I mean, we're not talking about decades or a 20-year profile of cost reduction. We're looking at significant advances in the last 3 to 4 years. So pre-2015, there was an average price greater than €100 per megawatt hour. And now we're looking at prices that are sub 50. So it's halving in a couple of years. And we're also looking at subsidy-free wind farms in more controlled regulatory regimes where you have governments that are willing to do early stage site selection and put more into the early stages of the engineering. And as a result, when those projects are bid, they're being won at a significantly reduced cost. So costs are falling. We've got larger turbines, which are all huge positives. But on a European and a worldwide stage, we also have deeper water and more challenging site conditions. This places more and more emphasis. If we have, say, 2 6-megawatt machines, we have 2 foundations, and we increase that to a 12-megawatt machine, obviously we now only have 1 location. And that in itself drives down the cost of energy, but it puts more stress on the foundation. So a lot of the research that I'm going to get on to talk to now is about foundation options. The seabed, how the seabed interacts with the foundations, and what we should be thinking about in an Irish context. So in terms of foundation options, this is not like a onshore project where your foundation options might have a small impact on your program, small impact on your capex, but the turbine is going to be your driver. The turbine for an offshore project is obviously a very, very important component. There's no one denying that. But the foundation stands up there as being one of the drivers and one of the potential risk items as well. So at an early stage in the project, we need to be thinking about what is the project strategy around the foundations and how will that strategy change if the ground condition turns out to be different. Typically, when I mention all of those projects that have reduced LCOEs and are bid at near subsidy-free rates, you're looking at monopile-based projects. So monopiles have kind of dominated the landscape in offshore wind certainly for the last decade. You're looking at 75% market penetration. And typically where you have sites that are non-monopile supported, they're for very specific reasons, such as shallow bedrock or very soft soils over significant depths. So why do we explore the seabed and why do we do site investigation is the obvious question. Sites, and there's a whole load of reasons for that, from the very early stages in terms of site selection and marine spatial planning. And in some ways, Ireland has an opportunity here to take advantage of the lessons learned in Europe over the years. There have been projects that have been consented, that have gone through zoning regimes and have been designated for offshore wind. And when it came to construction and when it came to design, they've been deemed non-feasible purely because of the ground conditions. So we don't need to make those same mistakes. We can go in early, we can get our site investigation done, and we can determine the site feasibility at an earlier stage. We can also identify if there's areas of the site that potentially are challenging. Geohazards could be anything from soft ground, shallow bedrock, through to gas deposits beneath the seabed, which would affect construction and installation. So we can use all of this information to optimize and to develop an array layout specifically for your project. And then as the project goes through the kind of development process, we can look at the engineering strategy, we can look at foundation concept selection, and take it through detailed design. But ultimately, the ground conditions will dictate that foundation concept, and that foundation concept has a significant impact on the overall capex cost. Now, the capex, the foundation percentage changes project by project depending on where you are, depending on what the concept is, depending on the water depths. But there have been projects where the foundations have been up to 30% of the capex value. So obviously, if you have a risk item there against that, and it transpires later on that you get a 5% change in that cost, it's an overall massive impact on your development price. Similarly, if there's an opportunity to reduce the foundations, there's a huge impact and a potential saving, which could make you more competitive at auction. So I think what I'm trying to get at here is the foundation can drive a step change in your development cost. It's not necessarily small savings, it could be a step change. So moving on to some of the research around this, and it's probably not that well known, but Ireland has been one of the leading countries in offshore foundation research for the last decade. And in some ways we have the oil and gas industry to thank for this, because the oil and gas industry don't have to be lean. They don't have to be as competitive when they're developing an offshore platform. Realistically, the capex for an offshore platform, while massive for oil or gas project, It's made up by, what, 10 minutes of drilling time, a few barrels of oil. We don't have that luxury in offshore wind. So we need to be more competitive, we need to be leaner. And if we're going to be leaner, then we need to understand the ground conditions, we need to understand the foundations much better. So oil and gas had the luxury of going over conservative, bigger foundations, bigger supports, whereas we need to trim all that back. So that's kind of resulted in a bit of a renaissance of research into foundation behavior over the last decade, which included University College Dublin as one of the kind of leading centres on that. So this is a project, the PISA project, which involved UCD, was led by Dong Energy and the Carbon Trust. We were involved on the numerical modelling side, and it tested at near full scale some of these units. For various reasons, it's expensive to test offshore. It's also hard to control. So in terms of getting good results out of these things, we like to test in an onshore environment where we can and simulate the offshore. So you can see from the scale of these, they're not offshore monopile scale, but they are at a sizable scale, where you're talking about millions of euro just for an experimental test program. And this is specifically looking at the behavior of monopiles, how they can be optimized further, how you can reduce on steel, and how those monopiles will interact with the turbines. Another piece of research that we've been involved with, you'll notice they all look kind of the same. Hard to make these photos look more exciting. That's usually why we throw a turbine in every now and again. But this was actually looking at fiber optic strain gauging and how to use fiber optic sensors within offshore foundations to look at real-time loads and real-time stresses. So this had never been done before. The most interesting thing about this photo is probably the location, which is the Roadstone Quarry out in Blessington, County Wicklow. And that's been a test site for offshore foundations for probably about 15 years now. And there it is again in all its glory. It resembles like a graveyard for scrap steel if you go out there today. This is Germany, but you wouldn't actually tell the difference. So this is Cuxhaven in Germany. Again, another sand and gravel quarry. They tend to be good locations to go when you want to drive pieces of steel into the ground. This was a project led by RWE Energy, and it was looking at how you can vibrate monopiles into the ground instead of driving them. So the impacts and the benefits of this are you reduce the noise, which is a huge issue due to the consenting regime in Germany, but also it increases installation time. So we had 4.2 meter diameter monopiles driven about 20 meters into the ground. Ideally, this would have been done onshore at full scale using kind of 6 meter diameter piles, but there was a tunnel between the fabrication yard and the test site, which was only 4.3 meter diameter wide. So there's a great picture where you can just about see these things squeezing through the tunnel. Our involvement in this project was coming up with the testing program, developing the testing regime, and doing quality control on some of the results. And you can see there, we're talking about projects of massive scale. I think the cost of this test was 6 million. But the benefits that it has for the industry are huge. And the installation time, if we can install a monopile in 5 minutes and potentially install multiple monopiles every single day, then the knock-on impacts of that for Irish offshore wind, where we can now take advantage of that, is huge. We've also been involved in some novel concepts. So this was a project done with Mainstream Renewable Power, another Irish offshore wind developer, who was looking at a project in the Hornsey zone of the UK. And we instrumented and monitored a novel twisted jacket structure to test its viability and competitiveness against the monopiles. A slightly different kind of concept. So this is a gravity-based structure that is initially buoyant and then floated out the site. So we did this project in collaboration with EDPR, Portuguese developer. And it was looking at building this kind of all in the dry with the turbine installed, floating it off and dropping it offshore. Specifically, we're looking at kind of the interaction elements with the seabed. Okay, so coming back to an Irish context and looking at constraint mapping in the Irish Sea. So this is an ongoing piece of research that we're doing with ICRAG. And the output of this is to look at where are the best sites for offshore wind? Where should we not be going? Can we identify that early? What should we be doing at a very, very early stage in terms of, we talk about marine spatial planning, to make sure that we don't start off on the wrong foot? Because if we're looking at, as a nation, reducing and getting to the lowest possible cost of offshore wind, the first thing you need to do is make sure you're at the right site. So this piece of research is actually working all the way around the Irish coast. We're about halfway around at the moment, and looking at all of the constraints that we know with the data that's available to us, be it infrastructure constraints, existing cables, pipelines, whatever it is, be it geohazards, seabed, bathymetry. There's a lot of information out there if you know where to look. And if you compile all of that into a GIS database, we can actually do early stage indications of where the most optimum locations for offshore wind. That also kind of indicates how much resource we can possibly tackle. Just one of the things that's cropped up out of this, I mean, there's enough sites off the Irish coast that are ideal for offshore wind. Had those sites been available in the UK, they would have been developed 10, 15 years ago. And instead, the UK are developing projects which are much more technically challenging in terms of water depths and ground conditions, because they don't have the availability of these kind of sites with good technical characteristics. As you kind of narrow in then on a specific site location, one of the things we're looking at is how you can use spatial GIS tools in order to identify risk areas and optimize array planning to get an LCOE from an early stage. Monopiles. So monopiles, we were asked about where we saw the kind of foundation concepts going about 5 years ago. And they asked kind of half a dozen people across the industry, and everyone said kind of monopiles probably have a year or two left, and then we'll have to transition into jackets for deeper water and for more challenging ground. That hasn't happened, thankfully. Monopiles have gotten bigger, costs have come down, and I don't see that changing. In terms of, as we look forward, monopile projects will be the cheapest projects that will be developed, and therefore that's probably where the market is going. So with that in mind, we've been looking at how we can optimize those further. None of the traditional rules for offshore piles apply anymore when you start looking at 10-meter diameter pieces of steel that need to be driven. So we're actually doing a lot of work with General Electric at the moment to see how we can optimize those and how monopiles are suitable for bigger capacity turbines. Just a couple of better looking images than before. This is multi-beam data, so bathymetry data from the Irish Sea, where you can pick up high resolution images and things like shipwrecks. So we had an idea a couple of years ago. How can we use shipwreck data to inform some of the kind of things that we're interested in from offshore wind? And one of those things is sediment dynamics and seabed scour. So what we did was we looked at the existing shipwrecks in the north part of the Irish Sea, where we had very high resolution data, and we mapped out kind of the scour regimes around each of those shipwrecks. And then by joining up the shipwrecks and joining up the scour regimes, you can see how the sediment dynamics have changed over time. And we're using that as a proxy for, if you put a turbine offshore, how are the sediment dynamics going to affect the turbine behavior. So that's pretty much it for me. So just to summarize, offshore wind projects are complex. There's a lot of technical challenges there. Fortunately, a lot of these challenges have been addressed in recent years. And Ireland has an opportunity both to take advantage of that R&D and also to contribute towards it. Thanks.